Good morning. This is 8:06, a little late getting started. I've been waiting for students to show up, but this is 8:06, Monday morning, the 10th of April. I believe that's right, isn't it? Yeah, I know it's April. Yeah, it is the 10th. Thought I heard on the radio this morning they gave another date, and I thought, that didn't sound right. Okay, so 10th of April, and this is supposed to be Math 237, linear algebra, but right now I'm the only one in the classroom, so hopefully some students will be showing up, but until they do, I'll go on and get started. Let me start first by going over a few of the announcements. This week is a rather strange week, so that's basically what I'm going to be talking about as far as announcements go. Tomorrow I have a doctor's appointment. It's 11 o'clock, and this is the hematologist who only sees patients on Tuesday morning, so I couldn't schedule any other time. I tried to schedule it during spring break week, but he was going to be on spring break too, so couldn't see him then. So anyway, it's going to be tomorrow. The appointment's at 11, but I have to be at the clinic for blood work by 10, meaning I'll have to leave campus by 9:15. So that means tomorrow I'll be leaving campus just as soon as that first class is over with and heading toward my doctor's appointment. So it starts at 11, and usually that late in the morning he's running a little late, so hopefully I'll be through by 12 and back here by 12:45, and I've got another class starting at 1:15. So I've already made up the trig class that I'll miss tomorrow. We made that up Friday, and then we'll be going, so I don't have to make up a class then. For that, we've already done that. But then I'll hopefully meet my 1:15 class on time. But where it comes down to you, my office hours normally on Tuesday and Thursday are 10:45 until 1:15. Tomorrow it's going to be more like 12:45 until 1:15 because of the doctor's appointment there. And I hope I can get back from the doctor's earlier than 12:45, but that's my I hope that's the outside time that I'll get back. It could be the median time I could get back. Just depends on how late they're running tomorrow. So office hours are curtailed tomorrow pretty significantly, somewhere around 10:45 until 1:15. And then, of course, I'm through at 5:45, so you can see me then too. So sometimes that class does finish a little early. They have lab and test tomorrow, so they sometimes will finish a little early. So you might be able to catch me before 5:45. I'll be on campus till pretty close to 6 o'clock anyway. Okay, Wednesday then's a fairly normal day as far as I know, as long as we don't have another rain day like we did last Wednesday. And then Thursday, another sort of fouled up day. We have the Honors and Award ceremony on the Birmingham campus. So what that means is I think classes are canceled from 9 o'clock until 11 or something like that. I've got to check my emails to refresh my mind on what it is. So that means I'll probably meet my 8 o'clock class in the morning and then have to leave. I don't know. I might have to leave by 8:30 to get there by 9. I've got to see what time things are actually going, what time they want faculty there, and that type of thing. So it's going to be sort of up in the air until I check and find out for sure. But I know my office hours will be messed up tomorrow too. On Thursday also, because I don't know how long. I can't remember when it starts and when they're projecting it to be over with, which is usually just a projection. So in other words, my trig class misses another whole class, and my pre-calculus algebra, I think, is going only, if we meet at all, it's only going to be for like a half hour or something like that. So both classes will be affected, but it doesn't affect any Monday, Wednesday classes. Thank goodness we've already lost a week and a half. We started on a Tuesday, so we lost the first Monday when we had Martin Luther King Day. That was a Monday, and then we had last Wednesday a weather day. So we've lost a week and a half that the Tuesday, Thursday classes have not lost. So they're catching up some because of all these things scheduled. Okay. Then Friday, I think is, Friday, sorry. Friday, I have an infusion on Friday, meaning I will not be on either campus at all. The infusion starts at 8. That means I have to be there by 7:45, so I won't be on the Birmingham campus at 7:45, and I won't be on either campus because I'll be in the infusion. Usually it goes until around 4:30 or so, and after that point, I'm not in any shape to drive back to campus, so I'm not going to be there at all. Okay, so I wish somebody were here, and I'd ask if there are any questions. Since there's not, we'll resume where we left off, which according to my book, mark in the book, is on example 2 on page 121. Chapter 3, determinants, 3.3, properties of determinants, and example 2, I believe that's where we left off. I've done this so many times, I can't recall if we've done this one in class or not. I know I've done it in class before, but we'll do it. Find the determinant of this matrix. Here's matrix A. If the pen will write, it will not. I don't know what its problem is. That's all that came out of that. So matrix A, there we go. Here's matrix A. 10, negative 20, 40. Seems like for sure we had done this one before. 30, 0, 50, and negative 20, negative 30, 10. And we're to find the determinant of that matrix, okay? First thing I see when I look at that matrix is a bunch of zeros in the right-hand column, of course, of right-hand digit of every number in every column and row, which means everything is multiplied, is a multiple of 10, including 0. 10 times 0 is still 0. So what you can do is factor out a 10, okay? And what does that leave you as a matrix? 1, negative 2, 4, 3, 0, 5, negative 2, negative 3, and 1. Okay. Now, that matrix is a lot easier to find the determinant of that matrix. Okay? So let's do that first. They just give you a number. They don't show you how they did it. If someone were here, I'd ask you what method would you like to use. I would hope that someone would notice that we have 1 0 in the matrix, which means that either the second column or the second row would be a really good candidate to use to determine our determinant. Okay? So I think I'm going to use the second column. Okay? So I'm going to draw a mild line through that. And in using that, so the determinant of A will then be, we'll use that negative 2 first, okay? But the negative 2 is in a negative position, right? Plus minus. So that makes it a 2 times the determinant of what's left when you wipe out first row, first column. And that would be, that determinant would be 3, 5, or what's left is 3, 5, negative 2, 1. Okay? And then the next thing we would do is, I'll erase my construction lines, you might call them here, that I just used for, oh well, I shouldn't have erased the middle column because that we're using, so that was silly. Okay? But now we'll do the third, the bottom, the third, the 3, 2 entry, okay, the negative 3. But that negative 3 is also in a negative position, plus, minus, plus, minus, plus minus plus minus. However you get there, it's going to be that plus, well, plus minus. I mean, however you want to do it. So it's minus a minus 3, which is plus 3, times the determinant left over there, which is 1, 4, 3, 5, or what remains is that. So what does this give us? 2 times, I've written something poorly here. All this is multiplied by, and this was from Theorem 3.6, the determinant of a constant times a matrix is the constant raised to the order of the matrix. So that 10 is 10, and this matrix is 3 by 3, so it's 10 cubed. So this is also multiplied by 10 cubed. Okay? Okay. I was looking at the way the book did it. They didn't talk about matrix A. They just used that matrix that was left over when you factored out the 10 and then went in and multiplied. But this is a little more precise if we're going to say this is matrix A. Okay, so that's 2 times 3 minus a minus 10. So 3 plus 10 would be 13. Plus 3, 5 minus 12 is negative 7. Okay? So this is 10 cubed. That's from your Theorem 3.6. And this will be 26 minus 21. And that's 10 cubed times 5, which is 5,000. Okay, 10 cubed is 1,000. So that's the determinant of that matrix. I'm glad we could factor something out and keep the numbers small until the very end and then multiply by the bigger amount. Okay, and I'll apologize, sorry, for several things right now. All this change of weather and or the pollen or something has my head totally clogged up, and you've probably already heard that by how I sound. And that contributes to what I'm about to say too. But I had a terrible night last night. I've had, now this is the, I think, 4th or 5th time in the last, let's see, about 31 years that I've had something called a heart flutter. It's not as bad as fibrillation or, something like that. It's a pretty mild thing, but it kept me awake most of the night. It just was, I had slept on, I rolled over sometime in my sleep and got into some awkward position, and that seems to be what triggers this. When it woke me up that I was having this little sensation that my heart was a little out of whack, it was beating too fast and not regular, and I got up and took a ibuprofen, hoping that would help, and then I remembered I had some pills from the last time, which was years ago, that the doctor gave me some pills for it. So I remembered I found those and did that. And we have a student here. Good to see. So anyway, I'm not at the top of my game this morning. I'm off feet. I was just explaining I'm yawning like crazy because I didn't have a very good night last night. So yeah, you can flip the lights. And I will actually turn on the projector. I've already marked you here. Good to see you. I guess you know that. Wait a minute. I just marked you here for last Wednesday. Okay, we weren't here last Wednesday. This is something looks suspicious. 10th, 11th, 12th, 13th. So you're here today. Okay. I set it on here, but since you're here, you probably won't go back and listen to it, so let me just go over office hours this week. I've got 3 events happening that are going to mess with office hours. First, and none today and none Wednesday, so that's sort of the good news. But Tuesday's office hours, I have a doctor's appointment at 11. He's a hematologist who only sees patients on Tuesday morning, so I tried to schedule it during spring break, but he was going to be on spring break too, so it was scheduled for tomorrow. Even though it starts at 11, I have to be there for blood work at 10. That means I have to leave campus by 9:15 in order to get there, get parked, and get in for blood work. So normally on Tuesdays and Thursdays, my office hours are 10:45 to 1:15. Not tomorrow, because it'll be, I'm just guessing it'll take about an hour for the appointment. It shouldn't, but by that time in the morning, things are usually running a little later. So if I'm through by 12, I'm hoping to be through by 12 and back here by 12:45. So normally my office hours are 10:45 to 1:15. Tomorrow they're going to be more like 12:45 to 1:15. Could be back earlier, or hopefully not. I could be back even later. Okay, that's Tuesday. Thursday is Honors and Awards Day. I don't know if y'all are aware of that. And full-time faculty have to be there, okay, dressed up and everything. So I can't remember exactly what time we're supposed to be there. It's going to be on the Birmingham campus, and I'm thinking we have to be there by 9. I've got to check on that. If we do, then I'm going to try to meet with my 8 o'clock class at least for a half hour, and then head over there at 8:30 to be there by 9. And I think the thing runs 9:30 to 11:30 or something like that. If that's the case, then I won't be back here much before 12, and I have class starting at 1:15 again. So my office hours will be messed up some on Thursday too. Rather than 10:45 to 1:15, it's going to be more like 12 to 1:15. So, and then on Friday, usually I'm on the Birmingham campus, 7:45 to 1 o'clock. Not this Friday. I have an infusion this Friday, and I have to be there at 8 o'clock. Well, it starts at 8, so I have to be there by 7:45. And if I have to do blood work, which I hope I won't have to do because I will have just done it on Tuesday. But if I have to be there by 7. So anyway, I won't be on the Birmingham campus at all, and I won't be on this campus at all, because those things usually go just about all day long. Usually I get out about 4:30 or so not gonna be on campus. All right. Was there something else I was going to say? I don't guess so. I did want to comment. This class is my first, and so far only class, have 100% papers in already. Way to go. Okay, all 4 of you turned in your papers. 3 out of the 4 have turned in the first test, and let's see, none out of the 4 have turned in the second test. So please get those in, because we're getting pretty close to having the 3rd test. All right, any questions before we get back to the lecture today?
So we have another test and then final?
Yeah, this test will coming up. I had hoped to get a little further today than it looks like we're going to. Hopefully you'll finish 3.3 today, but we'll see. And then we just got 3.4 to go. And we probably aren't going to do everything in 3.4. So I'll have the test ready for you. Well, I think I'll have it ready for it. I think I already have it made out. I just don't recall if I had it run off yet to give to you, because I thought we were going to have class last Wednesday and we didn't. To give to you on Wednesday. We may not be finished with 3.4, but I want to give you an extra weekend to work on it if you need to. So I'd like to have the other test in before then, okay, or by then. So, okay. And then wherever we pick up in chapter 4 until the end of the term, that'll be what's on the final. Probably won't be comprehensive, just whatever we cover from then on. Because basically all this builds on itself anyway. You'll use everything you've been using up till then. Okay. we just finished, I just finished example 2. That was before y'all came in. This is it. You can hear it. Go to Screencast-O-Matic. Well, go to YouTube. Probably late afternoon. I'll have that done. Wow, the more they keep coming. Okay, 3 out of 4 here. Good deal. Okay. Please listen to Screencast YouTube, because it talks all about my office hours being messed up this week. I've already gone through them twice. So listen to that and you'll hear. Okay. Basically, I've got a doctor's appointment tomorrow, so they're basically going to be something like 12:45 to 1:15. Then on Thursday, we got Honors and Awards Day, and there'll be something like 12 to 1:15. And then on Friday, I won't be on campus at all. Okay, so we just finished example 2 on page 121, chapter 3, determinants, section 3.3, properties of determinants. We just used theorem 3.6, that when you have a common factor in a matrix, every element in the matrix, you can factor it out before you decide to do the determinant. And we did that. So watch YouTube when it gets out there. And like I said, that'll probably be this afternoon before 3:30. It should be on YouTube. Okay. So it'll be on YouTube before that, but it won't be in the playlist until around then. Okay. Now, theorem 3.5, which told you if A and B are square matrices of order n, then the determinant of A times B is the determinant of A times the determinant of B. The determinant of a product of 2 matrices is the product of the determinants of 2 matrices. 3.6 was, if you have a scalar multiple of a matrix, then the determinant of that scalar multiple times the matrix is going to be the scalar multiple raised to the nth power. If it's a 2 by 2 matrix, it'll be squared. If it's 3 by 3, cubed. If it's 4 by 4, raised to the 4th power. Whatever it is, you're pulling it out and raising it to the nth power. They give formulas for determinants of products of 2 matrices and scalar multiple of a matrix. These theorems do not, however, give a formula for the determinant of the sum of 2 matrices. The sum of the determinants of 2 matrices usually does not equal the determinant of their sum. Okay? In other words, let me erase this. Any questions before I erase it? Okay. In other words, the determinant of A plus the determinant of B is usually not equal to the determinant of A plus B. You cannot say that. Okay? Cannot. Ever. I won't say ever, because they say usually. There may be a random case every now and then where those would be equal. Okay? For instance, if the determinant of B is 0, then that might work. I don't know. I haven't worked it out to see. Certainly if the determinant of A and B are both zeros, that would still work. Okay? So there will be occasional cases where it might work, but you generally can't have it. It's a lot like, and this may be a bad analogy, you can take the square root of a product of 2 numbers and separate that to be the product of their square roots. But you can't take the square root of the sum of 2 numbers and say it's the square root, it's the sum of their square roots. It won't work that way. Determinants are a lot like that too. Okay. So here's an example of that. Let's let A equal, and this is going to be, well, I'll write it as a matrix. A is 6221, okay, and B is 370 negative 1. Okay, you tell me what's the determinant of A. That is a 2 there. Huh? 4. What's the determinant of B? Negative 3. Well, what is A plus B? Pretty easy to do. 9, 9. That's a 2. Yeah. You did it before you. Wait. Oh. 6. Well, then you missed this one. I'm sorry. I thought. Okay. What's the determinant of A? That's a 2. 2. Right. Okay. So 9, 9. 2. 0. Right? Got it? And what's the determinant of A plus B? Negative 18. And what's the determinant of A plus the determinant of B? Negative 1. Nowhere close, okay? So don't think you can go around and make up some new rules here. Products work. Determinant of a product of two matrices is the product of the determinant of the two matrices. That works fine, but you can't do the same thing with sums. So don't even try it. Okay. Now, how about the determinant of an inverse of a matrix? Any guesses what you think that might be? Or you don't have any guesses? It's okay if you don't. It can be difficult to tell simply by inspection whether or not a matrix has an inverse. Can you tell which of the following two matrices are invertible? Here's A. 0, 2, minus 1. 3, minus 2, 1. And 3, I said minus 2 and wrote minus 1. 3, 2, minus 1. B is 0, 2, minus 1, 3, minus 2, 1, and 3, 2, 1. Okay, can you tell which, if either of those two matrices is invertible? Looking at it. If they're 2 by 2s, yeah, you could. You know, there's a real simple little way to do that. Okay? 3 by 3s and higher, not going to be easy at all. Well, yeah. Actually, it's easier than you might think with these two. Anyone make a guess? Didn't we? Yes. What were you going to say?
Is B the one that's
Is or is not? Is invertible. Why?
Can you choose a column and row it?
Ha! Okay, looking at the columns. If you look at these two columns, they are, related. Okay? Negative twice this is the same as that. So therefore we know that one's not invertible. That one, nothing like that works. Right off the top. Not saying it is invertible, but if those two, one of them is, B is going to be the one. Okay? Remember, when you're thinking matrices, you can look at columns as well as rows. Okay? And if you can column reduce a matrix and get a column of zeros, you know the determinant's not going to be, is going to be 0. This one fits that bill. Okay? The next theorem shows that the determinants are useful for classifying square matrices as invertible or invertible, just as we just did. Okay? Theorem 3.7 then should be nothing new. A square matrix A is invertible, which means, what's another word for invertible? Non-singular. if and only if, that's my abbreviation for if and only if, determinant of A, I don't like to write DET, I just like to do this, but I had already written it because the book had written it. The determinant of A, let me just do it that way, is not equal to 0. So if you can look and see if the determinant is 0, and we solve this without doing it, that these two columns are multiples of each other, then you know that you could column reduce that, and you would have a 0 determinant. Okay. All right, there is a proof there. I'll let you work through the proof. It's not that bad, okay? But we do need to finish the chapter. We've already lost another day of class, and we'd already lost a week before with the way they started classes and the Martin Luther King holiday. So we're a week and a half now behind Tuesday and Thursday classes. Of course, there's no other linear algebra Tuesday, Thursday class, but in my Cal 1 class, she comes in, the instructor on the Birmingham campus of her class, I'm here, where are you? I said, I'm a week and a half behind you. You know, so, all right. Before we move on, there's a little discovery here, and I think it's probably worth doing, if nothing else, as a review, okay? They give us the matrix A. It's 6, 4, 1, 0, 2, 3, and 1, 1, 2. Okay. Now, it says find A inverse. It says use a software program or graphing utility. If you have either of those, do them quickly and let us know. I'm guessing you don't. So let's do it by hand. How in the world do we do an inverse? Can you remember that? Do what? Yes, okay, you do adjoin the identity matrix to it, which would be 1, 0, 0, 0, 1, 0, 0, 0, 1. Y'all remembered that well, okay? And then we start row reducing. And what would we do? What would be your first move? Okay, he really loves his fractions. I've always known that, okay? Anyone think of anything else you might want to do? Oh, exchange the two rows, right? Okay, because then you don't have to do any division. You got it already. And that's going to be a 1, 1, 2, 0, 0, 1. And a 0, 2, 3, 0, 1, 0. And a 6, 4, 1, 1, 0, 0. Okay. We could do it Nigel's way, but I'd rather not this morning, okay? I'm not feeling up to it. Next. What's the next thing we do? It has been a long time, hasn't it? Okay. -6, row 1 plus row 3 is the new row 3, right? All right. So let's see what that produces. We're using row 1, 1, 1, 2, 0, 0, 1. Not doing anything with row 2, 0, ooh, I say 0 right at 2. 0, that looks pretty ugly, doesn't it? Don't answer that question. Okay. 0, 2, 3, 0, 1, 0. And what's the new third row? 0. -2. Second. Negative 11. 1. 0. Negative 6. Very good. Kind of a big boo hiss here. Gonna have to have some of Nigel's fractions here, but before I do that, I notice I can add row 2 to row 3 and get the 0 down that I'm going to want to have before I get my 1 in place. And being lazy, see, if you get the 1 in place, you're going to be adding and subtracting fractions, and that's what Nigel likes to do, but I don't. So I'm just going to add first, and then I'll go back and adjust. So I'm not using row 1, so it's 1, ooh. Okay. By the way, how far do we carry this? Do we do just row echelon form or reduced row echelon form? Say again? We have to do reduced because what do we want to have on the left? The identity matrix. So you got to do everything. So this is 1, 1, 2, 0, 0, 1. And we're not, oh well, okay. Let's add first. And what do we get? On row 3. 0, 0. Negative 8. 1. 1. Negative 6, right? Now I'm going to row 2 divided by 2. Got to do it sometime, but I wanted to add first while it was simple, and then redo, get this. So row 2 becomes what? 0, 1, 3 halves. Is that right? 0, 1 half, 0. Okay. Next. Oh boy. Another big boo hiss. Wait, no. Okay, yeah, I was starting to do the same thing, but let's go on and let's get that to be a 0 up there. Right? Okay, let's do that. So, negative, how would we do that? Row 2 plus row 1. That should get us a 0 up there. Okay? So we are operating, let's see, let's just write down row 2. 0, 1, 3 halves, 0, 1 half, 0. And well, we'll wait on that one. Okay, so do that. Negative row 2 plus row 1. 1. 0. Okay, that's why we're doing it. Okay. So negative 3 halves plus 4 halves is 1 half. Okay. And I think I can do the next one. What's that? 0. Negative 1 half. 1. Got it. Okay, now we'll do what you said. Row 3 divided by a negative 8. 0, 0, 1, negative 1/8, negative 1/8. I see why they said use a package. And this will be, say again? 3 over 4. Got it. Positive, because you're dividing by negative 8, so it changes the sign. Right. Got it? Same sign pattern, but just opposite. This is plus, minus, plus, plus, minus, so this better be a plus, minus, minus, plus. Okay. So, we got 2 more really fun steps to do. but we can do them. What would be the first one? Okay. Okay. Once you get a leading one in place, you don't want to be messing with it. So we don't want to mess with that either. We're going to have to use this one to get that to be a C. So how would we do that? If that were a 2 up there, what would you say? Okay, negative 1/2 row 3 plus row 1. That will do it for us, won't it? Okay, I'm beginning to wish I hadn't done this. Okay, this is why they said using a graphing utility. Okay, so we're using row 3, so let's write it down. 0, 0, 1, negative 1/8, negative 1/8, 3/4. Okay, do what you just told me. One, 0, 0. That's why you're doing it. You want a 0 there, right? Minus 1/2 times 1 is minus 1/2 plus 1/2 is 0. Okay. Now it gets fun. It's always fun. 1/16. Okay? So 1/16 minus 8/16 would be negative 7/16, right? Okay. And negative 3/8 plus 8/8 is 5/8. Is that what you said? Okay, good. What do we do to row 2? Pretty similar, only different. Negative 3/2 row 3 plus row 2. You see? Pretty exciting, huh? Okay. And by the way, I was starting to say to Emmanuel when the two of you came in, and I forgot to come back to it. I think I forgot to say this. It just shows how loopy I am today. I had a really bad night last night. It's happened like 3 or 4 times before in the last 31 years. I've had what they call a heart flutter, okay? And I think it came from sometime in my sleep. I turned over and was sort of scrunched up on my side, you know, somehow, and got my chest sort of compressed, and my heart just started messing up in the beating. It started going too fast and out of rhythm a little bit, but it's not what they call a fibrillation. Those are fairly serious. It's a flutter. And I got up and took some medicine and did other things and woke up about every hour. And I was also sweating, and it wasn't that hot last night. So I think probably I was running a little fever too. So I was up about every hour with it, you know. I doze off and then wake up, you know. So if I get, you know, and just lose things this morning, that's why. Okay, but let's go on. It's better now. It's not happening now. All right, so let's operate on row 2. What we got? Say again? 0, 1, 0. That's what we want. It's what?
You said you got the rest.
I can't hear you.
Did you say you got the rest?
No. I said that's what we want. Okay, I got the easy part. Oh, you wanted to get the easy part. I see. What's next? It's pretty easy. 3/16 until you get here. Okay, what does this give you? 3/16 plus 8/16 is 11/16. Okay, it was so much fun he left. Okay, and then what do we have here? Second, negative 9/8. Is that what you said? Okay, I thought so. Okay, negative 9/8. Okay. Well, we found the inverse of that matrix. Okay. No wonder they say use the software program graphing utility. Now, compare the determinant of the inverse of that matrix with the determinant of the matrix A itself. So let's first look at this matrix and let's talk about what we could do for its determinant. How would you find the determinant of that? What would be your very first step? Say that one more time. No, it may have been right. What did you say?
I was just repeating the question.
Say again.
I was just repeating the question.
Oh, yeah. What would be your first step? Before you start finding the determinant. Y'all were in the room when I did the last example, example 2.
Oh, see if anyone is a multiple of the other.
Yeah, see if there's a multiple. And I have a real good candidate for the multiple. Huh? No. Okay, I'm sorry. I see what you're saying now. No, what I mean is see if anything can be factored out of that to make the whole process easier. You're all too hard a worker, you know. You're going to do fine, but, you know, be lazy, okay, please, okay. What would you do? What do you want to get rid of is what I'm wondering. The what?
16, so we should factor out 8.
I can't hear.
Would you factor out the 8?
An 8? I would actually say a 16. Okay, I want to get rid of those denominators. Okay, I was taking the determinant of that thing. Okay, so let's factor out a 16th. That's 1/16. And when you do that, what will your first entry be? A 1, negative 7, that's the 5/8. How many 16ths is that? Say again? 10/16. So that would be a 10. Next. 3, 11, negative 18, negative 2, negative 2. Say again? 12. Is that what you said? Yeah. Perfect. Okay. I like that a whole lot better. Okay, do you? I thought so. Okay, now, still not going to be a super easy thing to do, but it is easier than what it would have been with all those fractions in it, I think. And since this is a 3 by 3, to me, the easy way to do this is to repeat, since there's no zeros anywhere to make life easier, repeat the first 2 columns. 1, 3, negative 2, and negative 7, 11, negative 2. Okay? And then we do our diagonals. What's that first one going to be? Now, since we're doing a determinant now, we're getting out of matrix mode into determinant mode. And what did theorem 3.6 tell us? If you do factor out a constant, when you're taking the determinant, what do you do with that constant?
Multiply back. So you multiply back.
Just it?
Multiply whenever you get the answer.
Okay. Well, just the constant? Look at theorem 3.6. When you're doing the determinant, yes, raises the power of the order of the matrix. And what order is this one? 3. So this will be, when we go to doing determinants, this is going to be 1/16 cubed. Okay? So we're going to put that off that till the very end, rather than having to deal with all this. But now let's go with this one. What's that first one? 11 times 12. Isn't that 121? Isn't it? Okay. Okay. Or one, is it? Yeah, I believe that's right. Something doesn't, no, it's 131. No, 132. 132. Sorry, let me erase that. I was going to say that doesn't look right. Okay. 132. Okay. Next. Yuck. What sign? I already put down a minus because I looked at that and saw 3 minus signs. That's going to be a minus. 7 times 18 is going to be 56, 126, and double that would be 352, I think. Is that right? Say again? 252? I don't know where the 3 came from. Okay. Next one. It's also going to be a minus. And that'll be minus 6 times 10 is minus 60. I hope that one's right, right? Okay. Now I'm going to get those lines out of there just so they won't be as confusing. And then I'll do my up diagonals. And these will be all subtracted. Okay. Minus, and this would be a minus, so that'll be a plus, and that'll be 22 times 10 is 220, right? Okay. And a minus that one, that will be a minus, and what will that be? 36, is that what you said? 36. And the last one, that's going to be a plus, and that's going to be 84 times 3. Ooh, 252. 252. Okay. Now let's see if we can add those things together. Yuck. First I'm going to add, oh, look at that. Is that a 252 and a minus 252? Woo-hoo! All right, I like that one. Okay, these two added together give us 352. They like those, don't they? 352 minus, these two added together give us 96, right? So that's going to be 256. Boy, I wasn't expecting that number, were you? Okay. 256 over 16 cubed. Now, the one nice thing about 256, if we did it right, that can be reduced. Let's factor it. 2 will go into 256, 122, no, 128, right? Well, 2 will go into 128, 64, right? Okay, and 2 will go into 64, 32, right? 2 will go into 32, 16, 2 will go into 16, 8, and 2 will go into 8, 4, and 2 will go into that. Wow, that's 1, 2, 3, 4, 5, 6, 7, 8. do this real quickly. 2 to the 8th. See if that's 256. If you got a calculator. 2 to the 8th. I hope that's 256. Good. Okay. That's why I said I was surprised to see that number pop up. So our numerator is 2 to the 8th, and our denominator is 16 is 2 to the 4th. 2 to the 4th cubed, right? So that would be 2 to the 8th over, that's a 2 to the 8th, 2 to the 12th, and that would give us 1 over 2 to the 4th, which is 1 over 16, right? Wow. Okay. So you get 1/16 is your determinant. No. Yeah, that's the determinant of the inverse. Now what we want to do is compare with the determinant of our first thing. Now I'm not about to go back and find out if we made any mistakes, so I'm going to just eliminate all this row. If we don't get the right answer, I'll say, Emmanuel made a mistake, you go find where it is, and I'm going on to the next problem, okay? Sounds fair? Okay, let's do the determinant of A. Now what would you like to do the determinant of A? We could do expansion and do our diagonals, but since this has a zero in it, that determinant's a lot easier to do. What would you choose? You have one or two choices. You have lots of choices, but which would be the easiest choices? Where is that zero? Row 2 or column 1. Okay. You choose. Which would you like to do? Row 2 or column 1? I don't really care much. Column 1. Why not? Okay. So let's do column 1. Okay. So the determinant of A would be take that first entry there, the 6. What position is it in? A positive or negative? Positive. That would be 6 times the determinant that's left over when we wipe out the first row, first column. And what would that be? Okay, you already did it. 6 times 1. See how much easier it is. I was going to write it out for you if y'all were having difficulty remembering that, but you weren't. So you just take the determinant of that. 4 minus 3 is 1. That was pretty easy. Now we're still going to use column 1. Stay with whichever you choose, but now we're going to go to the third row and use the 1 down there. Okay, and what position is it? Is it in? The 1 down here. Positive also, so it's going to be plus 1 times, and what's the determinant of that? 2 by 2 left over. 10. Okay, so this gives us 16. And what do you notice about this one? This was, the determinant of the inverse was 1 over 16. Oh my. It said, compare the determinant of the inverse with the determinant of the matrix. Make a conjecture about the determinant of the inverse of a matrix. If you just said it's going to be the reciprocal, you're absolutely right. Well, we'll see. So, we'll see that in Theorem 3.8. But, before we do that, let's do example 3. Any questions on that before we go? Okay, that was pretty long and arduous, wasn't it? Okay, classifying square matrices as singular or non-singular. Which of the following matrices has an inverse? Here is A, and this is 0 to negative 1. 3, we just did this, didn't we? This is the 2 at the top of the page, isn't it?
Yes, sir.
We've already determined that. We know that the determinant of that first one's got to be 0 because you can, I'm not going to write it down again, just go back a few slides and you got it. We didn't do the determinant of B, but if it says which of these has an inverse, and that implies only one does, B is the one with the inverse, they actually did it. And perhaps we should do that. Do you want to? Do you feel like the need to do that? We didn't determine its determinant before. Okay. Y'all are really being lazy now. You're catching on. Okay. No, but it's not that hard to do. What would you do to do it?
We already know A determinant 0, so we just find the determinant of B.
And how would you do that?
Choose the first row.
I would choose the first row, and it's pretty easy from there. You can almost do it in your head. Okay? So you can conclude that that matrix does have an inverse, so it is singular. First one does not. It's non-singular. Okay. Did I say that right? No. I said it backwards. The second one has an inverse, therefore it's non-singular. The top one does not have an inverse, so it's singular. Okay, I said it backwards. The next theorem provides a way to find the determinant of the inverse of a matrix. If A, let me write this down. If A is an n by n, so it's order n, invertible matrix, so they're telling us invertible matrix, okay, then that implies that the determinant of A inverse is 1 over the determinant of A. Okay? I like to write it that way rather than having to write DETs. Okay? It's a pretty simple proof. Okay? So, yeah, it's so easy, I guess we ought to do it. If it's invertible, here's what was given. Okay? It's an invertible matrix. So that means A times A inverse is equal to the identity matrix, obviously, right? Okay. Now, if we take the determinant of this, we're going to get the determinant of that, right? Would you buy that? They're the same matrix, so one determinant's got to equal the other one, right? And we know it's not going to be 0, okay? So, and what do we find out about the determinant of a product? Go back to theorem 3.5. Determinant of a product is come back one page to 3.5, bottom of page 120, theorem 3.5. It's what? Yes. What do you mean by that? Determinant of a product is the product of the determinants. And what is, on the right-hand side, what is the determinant of the identity matrix?
1 over.
It's what?
1 over.
Okay, yeah, determinant of the identity matrix. Why? Why? Yeah. It's a triangular matrix, isn't it? It's both the upper triangular and a lower triangular matrix. Choose either one. And what's the determinant of a triangular matrix? The what?
The product of the diagonal.
Yes, exactly. And what's the product of the diagonal of the identity matrix? 1 times 1 times 1 times 1 times, yes, exactly. 1. Okay, we knew that. Okay, so then all we have to do is divide both sides by the determinant of A. We know that the determinant of A is not 0 because it's an invertible matrix. So now we've just proven this. So that was, I thought, was going to be pretty easy. Okay, and it wasn't that bad. Like pulling teeth, but not bad. Okay. Baby teeth, okay. Now, it says find A inverse for this matrix. A is equal to 1, 0, 3, 0, minus 1, 2, 2, 1, 0. Find the determinant of A inverse. It did not, I think when I read it, I said find A inverse. No, that's not what it said. It's find the determinant of A inverse for that matrix. So, how should we do that?
We can find the determinant of that and then just...
Yes, all you have to do is take the reciprocal. Or we could do it the other way. We could multiply or adjoin the identity matrix to it and find the determinant of the inverse of that, and then find the determinant of that. We might wind up with something just as ugly as what we just did in that previous one, right? We don't want to do that again, do we? Let's not, and say we did, okay? So let's first find the determinant of A. Now, how would you do that? You say first column. That looks as good as any. I might go with the second column just because the numbers are a little smaller, but first column is perfectly fine. And you don't have any negatives there anyway. So how would you begin this? 1, if you're doing the first column, and you're using the 1, so let's do the first row too. What's that multiplied by? -2, okay? And then we'll jump to the third row, because the second row has a 0 in it, in that first column. So we'll do this one, and that'll be a +2 times what? Second? Did you say 3? Yeah, okay. And that would be -2 + 6 equal 4. So what's the determinant of A inverse? Say again? 1/4. And we didn't have to do any finding a inverse. We didn't have to wind up with a bunch of fractions or anything else, but we did run out of time, didn't we? Or almost jumping way ahead. Okay. So let's just write it down. Whoa, no. Where am I? That was example 4. Okay? Done. So we'll start next time with the stuff there. They went on and did the inverse, and look how messy that turned out. It's in the right-hand margin, or left-hand margin. It was a mess. Did find out it's the same, but my word, so much easier to do it the first way. So we'll pick up with there. We almost got to 3-3, okay? I finished 3-3. Homework exercises, do any of the odds 1 through 5, any of the odds 7 through 11, either 15 or 13 or 15 or both, any of the odds 17 to 23, any of the odds 25 through 29, and there I guess we'll stop and pick up the rest of those later. Okay, good deal. I'll see you both later today at various times, right? Okay. In fact, you two are at the same time. Yeah, okay.